Welcome to Class 16. This is a continuation of our investigation of building commercial towers, in this case with a steel frame. And the steel frame construction is quite typical when you get to structures of this height. Here is a typical section for a commercial building. There are many variations, but this is a good place to start. This is the finished floor. It is typically a raised floor to make room for utilities below the floor. And this gives you tremendous flexibility in developing your floor plan, and in renovating spaces you can create an infinite variety of configurations by having the utilities in the floor below you. Here is the structural frame. In this case it's a steel frame with concrete filled floor slabs. And this is the hung ceiling. And the space above the ceiling is a plenum, which will contain HVAC ductwork and lighting and fire safety and other utilities. The space below, of course, is the occupied space, and this suggests a window, but it's quite possible that you might have a completely glass exterior, but this suggests a window with a sill, and the space between the windows are called spandrels. They are panels that occupy the space between the windows. This arrangement is an important feature in commercial buildings. It allows you to proceed with the structural frame independent of all of the utilities. And that, of course, speeds up construction. There is no delay waiting for the various trades to install their piping and ductwork. You simply proceed from floor to floor, and the utilities and the ceiling, all of the interior finishes are applied later, and they are done independently. That's typically called tenant work. It's a very important profit center for the project, and since it is free and independent of the structural frame, the frame can go up that much more quickly. The project has reached the point where the cranes and equipment that have been walking around on the foundation mat are now actually in the way and need to be removed. At this point, you shift those responsibilities to tower cranes. And this particular tower crane has a unique capability. It's actually attached to the structural frame of the building. You may be more familiar with tower cranes that you see in the street. They are external to the building, and the tower begins at ground level and goes up the full height of the building. This is quite different. This tower is very short, and it climbs with the structural frame of the building. This is the tower, and below it is the foundation for the tower. This red frame is the bottom frame which is supporting the tower. It is also attached to the 4 columns by means of retractable lugs. And here you see a bracket on the column ready to receive it in its next position. Here is the fully assembled unit. It consists of this lower frame, the tower, this intermediate frame or upper frame, and this jacking assembly. The jacking assembly contains the hydraulic cylinders which actually do the lifting. And this, of course, is the bottom half of the tower crane itself. In this configuration, it looks like it is just about ready to jump, and I will show you that. I have a video showing the actual jump. Before the video, I'd like to go back in time. This is the construction of the World Trade Center Tower. It was done in the early 60s, and to the best of my knowledge, that was the first use of tower cranes. In this picture, it's a wonderful picture. The cranes hardly look like cranes. It's basically just a platform carrying the engine and a drum for the cable. It hardly resembles the cranes as we know them. I'd also like to point out the boom on this crane. This is called a luffing boom, and this designation of luffing boom simply means that the crane's boom can be raised and lowered, and usually indicates a much higher capacity crane. You may be familiar with tower cranes where the boom is in a fixed horizontal position and the load is carried by a little trolley that rides back and forth on that horizontal arm. Those are much lower capacity cranes. This is a higher capacity crane, and it was certainly the kind of crane they needed for the heavy lifts required here. As I say, this was the first use of a climbing tower crane in the United States. What is not at all clear to me is how this actually climbs. There are none of these supports visible in the picture. Of course, the supports may occur at a somewhat lower level where they're hidden, but I'm a little suspicious of that, and I'm wondering how this climbs. This is the first time I've actually given this any thought, and what jumps into my mind, and I guess if I was out there building this, I would have one crane lift up one of the adjoining cranes and raising it to the next position and then fixing it in place. Now, I have no idea how it was done, and it may be done exactly as I have described it. And if there's anyone in the audience who knows more about those details, I would really like to hear about them. One way or another, the cranes went up with the building, and I guess the assumption was they jacked themselves up the way modern cranes do. That may or may not be correct. Whether or not they had long hydraulic cylinders in those days that could actually lift a crane by one story at a time or more, I really don't know. I'm somehow questioning that, and just judging from the appearance here, it looks like they are not visible and some other method was used.